How's it going? This is group AHHI for our initials again. Austin, Hank, Hong, and Issei. This is our Pong implementation final presentation. So, what we're going to be going over today will include, we're going to go over the data path schematic. So just the overview of how we wired everything up and all the modules we created. Then after, we're going to be going over the FSM, how we designed that, what states, as well as instructions in the ALU. Then VGA, how we're going to be displaying our game. And then the IO, the input for how we're going to be taking in player controls for our game. We're going to talk about how we plan on finishing implementing the game and coding the game in assembly. And then also the challenges we faced. So as far as the CPU data path schematic goes, this was drawn by Hank. We're going to the way we had everything created is we decided to go with two different memory modules. We decided to have a instruction memory module and a data memory module. So when we read our instructions, we read our instructions to IMEM, and our IMEM's only gonna have the purpose of going through all the different instructions and reading them to the rest of the CPU. Whereas DMEM is going to store the information for VGA, as well as the positions for different things and whatever miscellaneous memory we need to store things in. The FSM is going to have the control for the rest of the entire CPU for the decode, reg file, muxes, and ALU. The decode takes in the instruction from iMemory and it splits it up into ROP1 to the immediate or opcode extended for the FSM and the opcode. The register file is the storage for all the different registers, which output for the ALU. And then the ALU obviously holds all of our different instructions and takes in the operation from the FSM. And then the muxes decide for certain things like what are we writing to the register file, or what we're going to be passing to the ALU, if it's an immediate or a register function. And now passing it on to Hank.
All right, so going a little bit deeper into the FSM, these are all the states that we have essentially for our FSM. So we go from idle to fetch, reg read, execute, write, update program counter, and then back to idle, or as we can talk about in a second, may or may not need to go back to idle each time. So one thing with the I-type versus R-type instructions is we have an I-type execute and an R-type execute, as well as I-type write and R-type write. And the difference between these is R-type write and I-type write, they set the mux control differently, and R-type uses the opcode extended and I-type uses just the opcode without the extended. So far, we haven't implemented all the instructions. We still need to do things like load and store. So we're getting onto that this week, and we may be able to remove idle entirely or just have it go into that state the first time that we run the machine, because then we can just go straight to fetch after we update the program counter. But one reason we might keep it is it might be nice to have like a little reset state where everything goes back to 0, and it might slow down the program like a little bit, but not enough to where the player of the game is really going to be able to notice it. So we're going to decide what happens with the idle state once the program starts.
And I guess the next would be the VGA and the IO. So using DMEM out as an output to read positions for the VGA, and using if statements to draw rectangles between the coordinates. So some of these coordinates would include the pedals and the score, and of course the ball that's moving back and forth. And we're going to stay true to the original Pong colors. And we might implement other colors that you can switch to using different switches. And we can memory map the IO.
So this is for game-specific implementation. We will keep track the position of the paddle and the ball. We will update these in data memory within a loop. When a collision happens, we update the ball's position and adjust gameplay accordingly. This is accomplished with a simple coordinate check and conditional logic. Squads are tracked using a simple totally marked system. So our future work, we need to write Pong logic in assembly. We will use memory mapped IO to provide input from the controller and keys and output to the screen. We will do VGA implementation for the visual output of the game.
All right. So these are some of the challenges that we faced as we've tried to complete the project. A lot of them have to do with just like time management. We spent a lot of time just deciding and talking about how we wanted to implement our game, what we wanted the input to be, whether that be an SNES controller or just like the buttons on the FPGA. Turns out that we just ended up not having enough time to implement the Nintendo controller or like audio sounds for like goal scoring or the pong ball bouncing off the paddle. So those were our like time constraint challenges, and just the finding time outside of class was a difficult thing for us, just because we're all busy college students and we work, and it just gets tough sometimes. But we got a good group, and we're happy that we've got this much done, and we're excited to finish it up. And that's it. Thank you very much for watching, and have a great night.
Peace.